types of pointers in C++. What are the different types of pointers we have? Let us see one by one. First one is void pointers. Void pointer, I will again talk about the pointers concept here. When I said int star p1 or char star p2, let me write the other also, float star p3, double star p4. If you see here, this char star p2, what does it means? Character star p2 means p2 is a pointer variable. P2 is a pointer variable. It is going to store address of which data type? That is character. Okay, it means when you declare a pointer variable, this indicates the type of the variable of which you are going to store the address here. Okay, this particular int, float, double, what does this indicates? It indicates that P3, what is about in this case, what is P3 here? P3 is a floating point, it is a integer pointer. P3 is a integer pointer variable. It is going to store address of another variable. That another variable is of type float. Okay, so P3 is holding some address like this 2000. This 2000 belongs to float variable. Right, I hope this is clear. Now, what is void pointer? Void pointer means void star p1, like this we can declare void star p1. It means p1 can store address. Generally, if I have here something like int char float, we say p1 can store address of this data type, right? This meaning of this general meaning of this statement is like this, void star p1. Its meaning is p1 is a pointer variable. It can store address of this type of a variable. But what do we have here? Void. When you declare pointer like this as void star p1, this p1 can be used to store address of any data type variable. Okay, like this, if I write int star p1 and character star p2, in these both the cases, see, p1 is meant, it is defined to store address of an integer variable. P2 is defined as a pointer variable, and it is mandatory that it has to store address of a character variable. P2 is designed or declared to store address of a character variable, like this. So, I cannot in P2 I cannot store address of an integer variable. In P2 I cannot store address of an integer variable. Same way, in this context, when I declare a variable as when I declare a pointer as void star p1, this p1 is free, it is freely available for everybody in the program. This p1 can be used to store address of any other variable. P1 can store address of any variable of any data type like int or char or float or double or whatever data types you have, right. This p1 now is a free variable because we have declared it as void. It means when you are defining a pointer, when you are declaring a pointer, suppose you gave a pointer double star p4. In this case, this p4 is fixed, that it can store only the address of a double variable. But when I declare a pointer as void star p1, I declare a void pointer, this p1 is a freely available variable. It is ready to store address of any other variable. You can assign address of integer, you can assign address of character, you can assign address of float or so on. That is void pointer in C++. Okay. So, void pointer in C++. Let us little see, right. It is a special type of pointer available in C++ which represents the absence of type. Okay. Void pointers are pointers that point to a value that has no type. It points to a value that has no type. Void star p1 means p1 can hold some address. This address belongs to which type? No type. That is only void. We do not know which address it is that. So, we can declare it like that. Okay. So, this means that void pointer have great flexibility as they can point to any data type. So, if you want to play with pointers, so many pointers you want to create in a program, just write void star p1, p2, p3, p4, so on. As on one you require, you can use them for integer, you can use them for character, you can use them for float. That is the benefit or advantage with these void pointers. Okay. So, this is about the void pointers. The next kind of pointer is invalid pointers. The second type is invalid pointers. It means some pointers which are not initialized pointers. How do we create pointers here? Generally, we write a program int a equal to 10. Then you will write int star p1 equal to ampersand a. What is the meaning of these two statements? There is a variable a which contains 10. It has some address 1000. There is a pointer p1. It also stores 1000. It is mapping like this. Its address is 2000. Right. This way we are assigning pointers to, you are using pointers to store address of another variables. What are invalid pointers? Pointers which are created int star p1, they are created but no address is assigned to them. Those kind of pointers can be treated as invalid pointers. Case number 1. Okay, you can have some uninitialized pointers. They were created as int star p1, char star p2 and so on, but they were not assigned any address into them. Those kind of pointers can be considered as invalid pointers. The second case, other case also, you see I have declared an array a, int a of 10. Now I want to create a pointer variable to store address of this a. Okay, so I am creating int star p1 equal to a. This way I can give. What is the meaning? A is an array of 10 numbers and starting address is some 1000. This 1000 I am storing in a pointer p1. This 1000 I am storing in a pointer p1. It points to this array like this. Okay. So, this is how we try to assign a pointer address of an array to a pointer, but the size of the array here is 10. Size of the array here is 10. If I give something no meaningless statement like this, if I write a plus 15, generally what is a? Address. Address plus 15 means it will go to the 15th box, right? It will go to the 15th box. Then do we have any element there? No, because my array size itself is 10. My array size itself is 10. But I am assigning a plus 15 to p1. This is invalid because a plus 15 does not exist. We know only up to a of 0 to a of 9 or a to a plus 9 only we know. Okay, we do not know what is a plus 15 value. So, if you assign these kind of values, so first case if you do not assign any address, this one, or second case if you give beyond the bound of the array, okay, out of bounds of the array if you give, these are invalid pointers in C++. Same in C as well. Let us see the next type of pointer, that is null pointer. Okay, before we go into null pointer, I will talk little about the linked list structure. Okay, if you remember the program implementation of linked list, whether single or double linked list, what we are trying to do there? We are trying to in linked list we are trying to create a node. No, first you will write like this. No, I will just write little about that. Struct node star, then you will write malloc of struct node. So you are creating a variable temp. You are creating or new node. Let me write new node here. So you are allocating memory to a new node. After that, what you are doing? You are writing new node of data equal to the data which is given as the input, and you are writing new node of next equal to null. See what you are doing here with these three statements in single linked list. With these three statements in single linked list, you are trying to create a memory block like this. Its name is new node. What am I storing here? Here I am storing some value 10, here I am putting null. What is this box? The second box is a pointer, right? It's a pointer. Okay, it's a pointer. We know that in a single linked list or in double linked list we have two pointers like this. which is used to store address of another variable or another node. So this is a pointer, but the beginning of the creating a node, we are assigning null. Why are we assigning null? Because there is no linkage now. This node is free now. It is new. It is free. It is not linked with any other node. That's why by default we are writing these 3 lines to create an empty structure, like this, and to assign some value 10 and to put null here like this. This third statement, if you see, we are assigning null to a pointer initially, because it is not mapped with any other node. It is not in the chain of linked list yet. It is just free and a new node. So we are putting null like this. Okay, same is your null pointer. Okay, null pointer is a pointer that does not point to any location but null. Same like in your linked list node creation. As soon as we create a double linked list node, what we are trying to do? We are trying to put the data 20, we are putting null and null on both sides. This is the first step we are doing. So this is a pointer, I am pointing it to null. These kind of pointers are called null pointers. Okay, so declaration can be something like this. See, type pointer name equal to null or 0, both are possible. You can even give like this. In linked list you can give new node hyphen next equal to 0 also can be assigned, because this is a pointer. When you are assigning 0, it becomes null there. Okay, so these two are the different ways of assigning null pointers, right? So why we need, what is the benefit of doing this? Okay, it means that particular pointer variable is free. It is not assigned to any memory address yet. Okay, right? So this way. And to check if null pointer before accessing any pointer variable, we will see this in due course. If you remember, we are talking about null. If you remember, while traversing the linked list, we are writing temp of next not equal to null, right? We are comparing like this. So this is, what is this null? This is a pointer only. You are comparing this with the null. It means the pointer, whether it is null or not. Okay, whether it is null or not, that we are trying to verify. And sometimes you don't want to pass the address of a variable, you can pass null pointer in that case. Okay, you don't want to pass address of a you don't want to pass a pointer variable, you can pass null pointer to that. Okay, this way. And we also know null pointer is used in linked list and trees and so on. So these are few benefits of null pointer. So till now we have seen about 3 types of pointers: void pointer, invalid pointer and null pointer. This is just an example to understand null pointer. I have created int star ptr and I have assigned it to null. Pointer is null. So you can check it like this. For checking, it is working. So ptr equal to null. When you write ptr equal to null, yes, pointer does not point to anything. That way we can give. Okay, this is about null pointer. So difference between null pointer and void pointer, little comparison of both. Before we understand the differences, let us again discuss what are these two pointers. Void pointer, it's a kind of a pointer variable, void star p1. This p1 can be used to store any type. So this void pointer indicates a type actually. It talks about a type. Whereas null pointer, it's a value. I am assigning some pointer like this, int star p2 equal to null. Okay, it's a value I am assigning in null pointer, whereas void pointer, it's a type, right? So what are the differences between both null pointer and void pointer? A null pointer does not point to anything. It is a special reserved value for pointers. A void pointer points to memory location that may contain typeless data. Okay, any pointer can be assigned null, but void, it can be only of type void. We cannot give for everything. Okay, all null pointers are equal, void pointers are different. Why null pointers are equal? See, int star p1 equal to null, int star p2 equal to null. This way, these all are same, p1, p2, whereas void star P1 void star P2. These are different. Why? P1 can be used to store address of integer, P2 can be used to store address of character. This is possible, right? Though it is void, but we are saying they can be used for storing address of any variable. That is why both are different. And pointer is a value, like I said, because it is a value assigned to the pointer. Void is a type of a pointer. Example, int star null and void star ptr. Basic differences. The major difference is it is a value and it is a type. So this is the difference. And what are the possible problems with pointers? What is the possible problems with pointer? The first one is dangling pointer. Okay, this you will be hearing it in future some courses of computer science. You will definitely hear about this dangling pointer. What is this dangling pointer? See, you allocated memory to a pointer. You created a pointer P1, you allocated some memory to it. Okay, after that you deleted the memory. Then you are trying to access P1. The best example is here. Okay, I am creating a float pointer using malloc. Malloc is a dynamic memory allocation technique. It allocates memory and it is that variable name is P, pointer P. Then after allocating memory, I am doing free. If you remember, in single linked list, we are using malloc statement, we are allocating memory during insertion operations. During deletion operation, always we are using free. Free of temp, we are writing free of P, right? During creation, you have to create a memory block like this. For that, you are using malloc. During deletion, you want to delete this block. So for that, you are using free function. Okay, so this statement I am allocating memory, immediately I am erasing its memory. After erasing memory, I am trying to put some value. So the pointer does not exist. So pointing to a memory location that does not exist is, then that kind of an access will give you dangling pointer error. Okay, dangling pointer, pointing to a pointer which does not exist. Next one is wild pointer. Wild pointer means generally pointers are used to store address like this ampersand a. So this P1 can hold address. Address, you generally little about programming if I talk here, if it is a 32-bit machine, the pointers address are something like 140287669. Address is something like this. If it is a 64-bit machine or some different type of machine, your computer, it allocates address in hexadecimal format. It allocates memory in hexadecimal format. Okay, so indirectly both are addresses only. Okay, this P1 holds address, but instead of address, if it is allocated some value that P1 equal to 5, P1 equal to 10, something like this, this is not an address. This cannot be a valid address. Address should be 8-digit long or it should be in hexadecimal format, 8-digit length and maybe in hexadecimal or not in hexadecimal. That should be the length of the address. But if I give something P1 is a pointer, it is meant to hold only the address. If it is holding some value like this 10, 5, those kind of pointers are called wild pointers. Okay, not even null. Pointer which stores values which point to some arbitrary memory location, that memory does not exist. Those kind of pointers are called as wild pointers. Okay, those kind of pointers are called as wild pointers. So if we summarize, we have seen about void pointer. Void pointer can point to any type of pointer variable. Invalid pointers which pointers which are not assigned any values, right? Null pointers, you can assign it null or 0. And then we have seen about problems with pointers. Dangling pointer means you are trying to access a pointer which does not exist, or it was created and deleted but it does not exist now. And wild pointer means pointing to a memory location which is arbitrary. It means it is not a valid memory address or a valid memory location. So this is about pointers in C++.